back and we're gonna be doing this example in 2D kinematics. It's a vector question. It should be okay. And if you need like more like reference, if you need like study material, because like these videos do require like a prerequisite, you should watch the Yale ones, the Yale lectures. They're really good. You can find them on YouTube. Anyway, example 2.3: a river flows from west to east. Never eat soggy waffles. So it's this way. There's a river, and this is a V river, and it has a current of 2 meters a second. Um, the river is 40 meters across. Okay, so that means like it's like 40 meters. It's like so I think it means this across, like type shit. Like what I'm saying? Like okay, and then Alice is located on the southern side, and she can paddle her boat at a constant 5 meters a second. And what direction should Alice paddle if she wants to reach the north side in the shortest time? So yeah, it's 2D kinematics, which means we just look at the x component, right? Or we look at the y component only. Because this V river, it doesn't really matter. Like you could say, hey, it's moving this way and it's moving this way, and this is the overall velocity. That's true, but that doesn't like change the individual components. All this does is just make the boat go like this way while it moves this way. It's still the same thing. So yeah, the direction she should paddle to reach the north side in the short amount of time will be completely forward. So I think I should explain this a bit more. So let's say I have a ball, right? And I have a ball, but this time I give it a VO. Let's say I have a ball, right? Okay, look, I never. Oh my god, I can't articulate my thoughts. Anyway, let's say I just drop the ball, but for this one, I drop it, and for this one, I drop it. But this one, I give it initial velocity in the horizontal direction. And basically, what it is which one will reach the floor the quickest? And the answer is they'll reach at the same time, right? Because think about it, you just break the components. It doesn't matter that this only affects the x direction. It does not affect how it will go downward, if that makes sense. The downward is for the downward, the forward is for the forward. The forward does not affect how the downward works. You know what I'm saying? So this will still fall, and this will still fall. It'll just move a bit like more. Um, this way. I think if you need like a good reference, you should watch Walter Lewin. I know I said you should watch Yale. Watch Yale too. Yale's usually recommended. If you read Kevin Zhao, that guy's like the goat. If you read it, he says, "Hey, you should do Yale." But if you're just starting, you should probably watch the MIT ones. Walter Lewin. Yeah, you should probably watch those ones because they have a lot of demonstrations. Even though like it's pretty easy, like the theory is really short. They don't really teach you that much. It it does talk about like the intuitive process a lot, and I think that's really important. When you're done with that, you can probably watch the Yale. But if you're not like a fan of like watching things, just look at the books, like HRK, I guess HRW. Yeah. So that's my little rant or going back. So again, I just want to prove this one more time. You're like, why is it completely straight? What if we just did something different, right? So this is the right now. Let's say I bent it this way. Okay, wait. Okay, I think let's say I bent this one a little like this way. You see how in the grand scheme of things it looks shorter? Because it is shorter. It lost some of the velocity. If we bend it this way, it won't be as tall as it forward. Because remember the X is for the X. So this just makes so if I do this, if I bend it like this, it will just give it more the lost y component, this missing like y component, it actually goes into the x component. So instead of moving upward, it just moves sideways more. If that makes sense, because like it's like all conserved. You know what I'm saying? Like if I lose some y direction here, I had to like compensate for it, and where I compensate is the x direction. Hope that makes sense. So yeah, that will be the first one. This will be go completely forward. Nice. So, what direction should Alice paddle if she wants to reach the north side directly where she started? So, here we have the boat, we have the V Atlas, and we have V River. And we want to move these vectors in a way where it'll result in a straight line. So right now it's like this, right? Right now this is a V total. But what I can observe is if I just move this VA, this V Alice here, and keep the same VR, because you can't change the V River, you can't change it. So it's always going to be there. It's going to result in a straight line for the V total. So that's how we do it. Yeah. Um, how much? Oh, they want direction. So just think about it as a triangle. The V Rivers 2, the V Alice is 5. Even though they're not distances, it's like the same thing. It's just vectors. It's not that deep. What is it? Sine -1, 2 over 5 equals theta. Desmos time. Desmos time. My teacher, he was talking about how like we should use Desmos for tests. I completely agree with him. Okay. Anyway, this is our answer. Um, so was it like 23.6 degrees? Nice. So that's the direction. Now it wants to say how much longer would it take to cross the shore compared if she cross in part A. So in part A, it's just T equals D over V equals to 40 over 5 equals to 8. 8 seconds. Seconds. Always write your always write your units of measurement. You know, I remember I was watching the Yale guy, and in the first lecture, he was like, yeah, you always have to write your units of measure. You have not earned the privilege to not write them. So yeah, I'm still like under that. You know what I'm saying? Not really. I didn't write meters here. It's whatever. Play the game however you want to play. Don't let someone else tell you how to do things. You know, eventually you'll learn. Yeah. Okay, so 8 seconds is here. Then what if we did this? Yeah. This is we need to find this component. So what is that? Just Pythagorean theorem, right? A squared plus 4 equals 25. A equals square root 21. So that's going to be this component, v equals square root 21 and 40 over square root 21 equals, I don't know what that is. I'm not like a genius. I don't do math counts. What the hell? Okay, so it does in fact take longer. It takes this long. Let's move it back up. Oh my god. It takes like 0.729 seconds longer. Yeah, so that's the entire problem. It was pretty simple, actually. Yeah. So, how do I don't know how to make a good outro. Anyway, yeah, we did it. Yay. Yeah, just comment if you have any questions. Yeah, thanks for watching, I guess. Yeah, thank you.